All right, guys, we are going to continue with the next lecture. Picks back up in our notes. Sorry about the audio, but I'm recording at school again, and so this is the audio that you get. So in Roman numeral 3, we're now talking about the dermis. So we've moved below the epidermis, and we'll be talking about this large region right here called the dermis. So think about, for perspective, everything that we talked about previously with all of the different stratum granulosum, stratum corneum, all of those layers exist in this small band right here. Next, we talk about the dermis, and we'll wrap up talking about the hypodermis as well. So the dermis is the thickest of all three of our skin layers: epidermis, dermis, hypodermis. This one is the thickest. Within, we see a breakdown of two different layers. And so we'll talk about the two layers that make up the dermis. There's a whole lot of connective tissue here in this layer. And that connective tissue allows for the function of the dermis, which is flexibility, primarily, lots of stretch, and then sensation. We'll see some sensory receptors embedded in this layer that adds to that sensory function of our skin. So here are the two layers of the dermis. It's a little bit trickier because there's not a hard divide, but you can see in this diagram down here, you can see this top layer, which has some almost like ridges, mountains, that is lighter in color. And then just below it is a darker pinkish red, and you see all of these horizontal fibers. That would be the second layer. So the top layer is called the papillary layer. It sits just below the epidermis. It makes contact with the epidermis. This is how the epidermis actually receives blood flow. So there are tiny capillary loops that exist here in this papillary layer. And so if you follow my arrow, these are little capillary loops right here stemming off of a larger artery. You see these capillary loops come up into these ridges and supply the epidermis above with blood flow and nutrients. Oh, the picture covered it. There are also these little tiny, up here is these little like bulbs. These are called Meissner's corpuscles. They detect pressure. And so one of the functions of this layer is adding a sensation effect. And the sensation that's being detected really is pressure. The reticular layer is deeper in the dermis. It makes up the majority of the dermis. So about 80% of the dermis is reticular. What we see here is a layer that sits above the cutaneous plexus. Now, the cutaneous plexus, that is a combination of the arteries and the veins that exist down here close to the hypodermis, the last layer that we'll talk about. And so because you have this cutaneous plexus down here, you see vessels coming up, extending up through the reticular layer and forming these capillary beds. I think a second ago I pointed to this as a capillary bed. That is a Meissner's corpuscle. This is a capillary bed right here. So the reticular layer acts as sort of a conductive pathway between the big blood supply all the way up here to these capillary loops. We see in this layer another sensory structure. So these larger bulbs, down here's one, and there's another one over here. These are a second corpuscle. This is a Pacinian. And so this is going to detect vibrations. So between the two corpuscles that you see here in the dermal layer, one, the Meissner up here in the very top, is going to detect pressure. And the Pacinian, the larger one down here in the reticular layer, is going to detect vibrations. These fibers that run horizontal in the reticular layer, these are those stretch fibers. So collagen and elastin, those are our two primary connective tissues here that are adding to that flexibility function of the dermal layer. When you disrupt collagen and elastin, if you've stretched them beyond capacity, or just over time as you get older, these proteins start to break down, we see stretch marks and we see wrinkles. And so if you have seen or even have stretch marks or wrinkles on your body, that's really damage done to the collagen and elastin here in the reticular layer. If we go below the dermis, we hit the hypodermis. And so the trick to the hypodermis is that it's not technically a true layer, but in most diagrams it is represented as the third layer. So we'll talk about it as a layer, but just know that it's not technically a, quote, true layer. What we see down here in the hypodermis is mostly fat. So these little yellow blobby things in the diagram, all these little yellow blobs, those are adipose cells, which are fat. And then you see the cutaneous plexus, so blood supply. So the primary function relates back to the structure. The hypodermis's function is to store fat, which acts as a shock absorber. It can also act as an insulator, so it can help with temperature regulation. We also see a function related to blood storage and blood supply because you have that cutaneous plexus. Let's talk for just a second about where color comes from. As we've seen these different layers, the structures that exist within the layers, I want to talk about the variety of skin tones that might exist. I want to talk about blushing or flushing. And then our Oompa Loompa lets me talk about certain times when our skin tone can pick up pigments from our environment. So let's first talk about melanin. Melanin, we know, is produced by the melanocytes that are in the basal layer of the epidermis. There's two types of melanin that can be produced, and the different variations of those two types of melanins give us a wide range of skin color. And melanin production is genetically controlled. So if you're looking for a genetic component tied back to skin color, yes, the melanin production is genetically controlled. So here's the two types of melanin that we can produce: eumelanin, eumelanin, which is more of a brownish black pigment, and then pheomelanin, which is a little bit more red and yellow. And so the combinations of these, again, sort of blending together in different concentrations, give us all of these different possible unique skin tone colors. Keratin is my reminder here of the Oompa Loompa, right, from Willy Wonka. So keratin is a yellowish and orange pigment that actually comes from the food that we eat. And so I'll tell you a quick story. When I was a new mom, our first kiddo was born, I did not know what I was doing. Still don't know what I'm doing sometimes. But our son, Jack, his skin started to take on kind of an orange tint, and I panicked. So I took him to the doctor, and the doctor kind of looked him over and said, well, does he enjoy sweet potatoes and carrots? Oh, why, yes, actually, he loves those. He's eating too much of the food that contains keratin, and it's collecting in his skin. And so it's an important thing to have. We need keratin to be able to make vitamin A, but if you eat too much, it can collect in your skin and turn your skin a bit of a yellowish color. So keratin comes from our diet and can tint our skin color if we have too much of it. Hemoglobin is my last reminder here. So this fella down here, flushing or blushing, hemoglobin is really coloration due to blood flow. And so the pinkish reddish tint of your cheeks or of your skin that are the result of blood flow from your hypodermis traveling all the way up to the capillary beds in your dermal layer, that's really why we're flushing and blushing. All right, I would like to introduce you to burns because when you next are either in class or have your next at-home day, if you're an A student, you're going to see specific burn types. So let's do a little intro into burns. Burns can be caused by a variety of reasons. Electrical burns. This is an electrical burn. That's the heel of a person. Usually electrical burns enter the body and then exit at a grounding point. So if you're standing on the ground, they're usually exiting through your heels. And so this is the electrical burn as the electricity exited this person. Chemical burns from any kind of a chemical. Thermal burns, so temperature related burns. If you have touched a hot plate, if you have been in a fire, if you have spilled a hot liquid, a thermal burn. And then I want to specify a radiation burn because many of us are familiar with chemotherapy and radiation as treatment for cancer. So radiation does collect really high dose radiation to a certain part of your body to target cancer cells, but it also can burn and scar the tissue as well. The immediate issues or problems related to burns actually isn't the pain of a burn. It's the fluid loss and the potential for infection. So as you start to burn your skin, remember your epidermis is a waterproofing layer. And so if you burn through and remove that epidermal layer, you are at risk for fluid loss. If you are burning up tissue, that's where fluid is stored. You are at risk for fluid loss. And anytime we lose fluid, we are concerned then about electrolyte imbalances. There are some really critical electrolytes that keep our body functioning, especially our heart. And so muscles in general in our body, but our heart being a muscle. So electrolyte balance can become an issue as we lose fluid. And then, of course, anytime we remove that outer barrier that our skin protects or that our skin provides as protection, we are at risk for infection. So this is where I'm going to leave you. I would like for you to create this chart in your notes. So we are going to learn the next time we're together or the next time you watch a video, you are going to learn about first, second, third, and fourth degree burns. And so as we learn about these burn types, we are going to be concerned with what layers, we're connecting it back to LT1, what layers of skin are damaged in these different burn types, what symptoms would someone experience, and then how would we treat that person or what are their potential outcomes. So make this chart so that it's ready to roll for our next lesson together.